Welcome back, class. Today we're beginning to deal with true exponential equations. Now, we started exponential equations in the first piece of chapter 7, way back before the MCAs. Now, what we talk about now are exponential equations of this form. All right? Now, there's two strategies we're going to talk about today in terms of solving these exponential equations. Strategy 1. When the numbers of both sides of the exponential equation can be written in a common base, rewrite it and then set the exponents equal to each other. Now what I mean by that is look at our first example. 2 to the 3x plus 1 equals 16. So what I notice from this is the exponent has a base of 2, all right? And the other thing that I notice is that 16 can be written as a base of 2. 16 is 2 to the 4th power. So if I can do this, if I can rewrite this where they have the same base, what ends up happening is the only way that this is a true statement is if those exponents are simply equal to each other. Once you realize that, well, now it's just common algebra from there. Subtract 1 from both sides, divide by 3, and you get your answer at x is negative or x is 1. But again, the goal here, the only way that this works is the fact that I can write these as a common base. Now, if you look at the next one, 16 to the 3x equals 18. Well, this one's not as easy of a base change, right? Because 16 can't be written as a base of 8. However, both can be written as a base of 2. So sometimes you're going to have to change both sides to be the common base. So here, power over power, so I multiply those, so I get a 12x, 4 times 3x gives me 12x, equals 2 to the 3. And now again, I've accomplished my goal. They're both written in a common base, so all I do is I set those exponents equal to each other. It's the only way that this can be a true statement. Now divide by 12. I get x is 1/4. All right, 27 to the 3x equals 81. Again, you can't write them in base of 27. However, there is a common base it can be written in. Both of those are powers of 3. So I'm going to change this. So 27 is 3 to the 3rd. 81 is 3 to the 4th. So on this side, I multiply my powers. 3 times 3x gives me a 9x. Now, once again, I have them in a common base. So all I have to do is set those exponents equal to each other. Divide by 9 so I can solve for x. And I get x is 4/9. So in our next one, now this one should be a little bit easier because 5 is already in its most basic base. 125 can be written in that base. So I'm going to change 125, that is 5 to the 3rd power. Once I recognize that, now all I have to do is set my powers equal to each other, and I get x equals 2. So again, that's our most basic strategy, okay? First strategy, write them in a common base, and then all you have to do, set the exponents equal to each other. Now, it's not always that simple though. So let's look at this. When the numbers cannot be written in a common base, we can use logarithms to solve them. So in these examples, when you can't just take a common, you can't write them in a common base, you can use logarithms. So in this first example, I'm going to take the logarithm of both sides. Oh, I'm sorry, I started writing that wrong. So you can take a logarithm to both sides of an equation, just like any other operation. All right, well, now let's see what happens. Well, I have this 3x up in my exponent still. Well, remember, once I take a logarithm, one of my properties is those come down. So I'm going to write this 3x log base 15 equals log base 285. Remember that in a logarithm, an exponent can come down as a multiplier. Now, there's a reason that that is so important in this case. Because now I have x, not as an exponent, I have x just being multiplied by other things. So what that means is if I take both sides and I divide off the 3 and the log base 15, that gives me x completely by itself. So x is going to be log of 285 divided by 3 log base 15. Now, of course, you want to actually type that in the calculator. You want to actually get a number. So I'm going to take log of 285 divided by 3 divided by log of 15. And x is going to be about 0.70. That's going to be our answer. Now, make sure you type this in and try it, because if you type this in incorrectly, you're not going to get the right answer. So I do urge you, make sure you write this down, okay? And check it that you're getting the same number as me. Don't just take my word for it, because there are those slight little calculator techniques that you're going to have to know. Now the cool thing is, this is kind of the structure of all problems of this second strategy, all right? So you isolate the exponential part of the equation, log both sides, and then rearrange from there. So let's see it again in action. So here, 130 can't be written as a power of 5. So I'm going to log both sides of this equation. Oh, not 5, 130 should go over there. And again, what logging this does for me is it lets me take the exponent and it brings it down as a multiplier. So I can bring this 2x out front. And the power of that is now that I have x just multiplying things, all I have to do is divide everything off of this side of my equation. So divide off the 2 log 5. So all I have left is my x. And when I typed it into the calculator, again, make sure you're typing it in carefully, log of 130 divided by 2 divided by log of 5. If you type that in correctly, you get 1.51 as your answer. All right. Let's take a look at our next one. Now, this one will take a little bit more work. Now, why do I say that? Well, because notice my exponential piece to my equation, and this one is no longer by itself. Creates a little bit of a dilemma. So what I'm going to do, I see this 1 out here, this 1 by itself. Well, I'm going to subtract that 1 from both sides. I want to get rid of it from that side of my equation. Now here, be very careful when you're doing this. Subtracting off that 1 is not taking away that negative that's with my 4 to the x. All right, that negative stays. Has nothing to do with the fact that I'm subtracting 1. Negative 60 minus 1, again, be very careful, gives you a negative 61. Now you may be getting a little bit concerned because you know you can't take the logarithm of a negative number. We've already had that conversation. Well, the nice thing is both sides are negative, aren't they? So if I divide both sides by negative 1, all what I'm doing is actually canceling both of those negatives. So that's going to be my next step, okay? So I'm going to divide negative 1 on both sides because, again, all that's going to do is wipe out both of those negatives and make it positive. All right, so hopefully you're still with me. Now I'm going to need a little bit more space, so I'm going to erase this and move up some of the work that I've already done. So we're to this point right here. And what we know is we can't write 61 as a power of 4. So I'm going to have to do a little something else here. So I'm going to log both sides of this equation. Remember, that's always our strategy when you can't you can't write both in a common base. Once I've done that, remember, now that I have an exponent with the logarithm, remember the exponent just drops down. So I get x log of 4 equals log of 61. And then finally, to get my x by itself, I'm going to divide both sides by the log of 4. So my x equals log of 61 divided by log of 4. And that's something I can just type into my calculator. Log 61 divided by a log of 4. That gives me about 2.97. All right, last one of this type. So just like the first time, notice my exponential piece of my equation is not isolated, it's not by itself. So the first thing I'm going to do is I'm going to subtract off that 1 from both sides. So I'll have 3 to the 2x equals 189. All right, it is very important that you isolate that piece of the equation. Now that I'm this far, notice I can't write 189 as a power of 3. So what's my strategy? I take the logarithm of both sides. Once I do that, once I take that logarithm, I can take the exponent and I can bring it down as a multiplier. So I'm going to get 2x log of 3 equaling log of 189. Now, I need some more space, so I'm going to erase some of this early stuff. So I can scooch this up. So we have 2x log of 3 equaling log of 189. Now that I'm this far, I'm going to divide off everything with my x. So I'm going to divide off the 2, the log base 3, That will finally get me my x by itself. And now I can type that into my calculator. So log of 189 divided by 2 divided by log of 3. That is going to approximately give me 2.39. All right, so those are the basics. Now, I do want to take a moment. I want to apply this to a word problem for you so you can see an application of this. So, what is a sustainable, renewable, natural resource when you manage forests properly? Your lumber company has 1,200,000 trees. You plan to harvest 7% of these trees each year. How many years will it take to harvest half of the trees? All right. So, looking at this, this is going to be an exponential equation. All right. So look at this. The first thing we're going to do is write an equation for representing how many trees there are. Now, hopefully you remember, this is way back from the beginning of chapter 7. But if we're trying to check how many trees there are, remember, we take the beginning amount, oh, then we multiply it by the, oh, that wasn't supposed to happen. I apologize for that. Now, after we calculate that, now we need the rate. Well, if you're harvesting 7% of the trees, how many trees are actually left? Well, remember 1 minus 0.07 means 93% of the trees will be remaining. Okay, you take 1 minus that 0.07 because remember you also always need percentages. Now what they want to know is how many years will it take to harvest half of the trees? Well, if we're starting with 1,200,000, if we want half of those remaining, all we do is we take that number, we divide it by 2. So for my y, for the number of trees I'm looking for, I'm going to be looking for one that are 600,000 trees left. Now what we want to know is how many years that'll occur. So I want to know the x that will lead to that many trees. All right, well, I see something exponential here. So the first thing I'm going to do is, again, I need it by itself, the exponential piece. So I'm going to divide both sides by the 1,200,000, all right? Because again, it needs to be completely by itself. So that'll leave me with 0.5 over here, then 0.93 to the x over here. All right, well, I can't write them in a common base, so I'm going to natural log both sides. So I'm going to have log of base 5 equals the log of 0.93 to the x. Again, important thing, I can bring that x down. So log to the 0.5 equals x times log of 0.93. Just like before, now I'm going to divide by that log of 0.93. I need to get the x by itself. So I'm going to have log of 0.5 divided by a log of 0.93. I'm going to divide it from both sides. And that is something I can type into my calculator. So the answer is 0.955 years. So basically, 10 years, I will be down to half of my trees. All right, thank you for joining me for this. So please make sure you have all of this written down and then come back to class prepared to do your practice work.